Yeah, hi. So thank you, the organizers, for inviting me. So this will be a very different talk than everything you heard before, but I think it's makes sense because we will have afterwards a panel discussion, and the panel discussion will be about sort of how it is to be a bioimage analyst. So this talk will be actually no new methods or anything. It will be just my current attempts of organizing bioimage analysis service at EMBL. And I have been at EMBL for several years, but since middle of this year, things changed a little bit. So I'm now a service team leader in the new data science center at EMBL. And so my job is to support EMBL scientists and visitors in the reproducible extraction of biophysically meaningful, that's my personal addition to it, information from bioimaging data. And so I don't really have yet an official team on my own because I just started, and also the whole data science center just started. So what I did was basically identify all the people at EMBL that are already employed and that have some fraction of their contract saying they should do bioimage analysis support. And that actually is this crowd of people, so quite a number. And then I organized or friendly asked all of them whether they would like to be part of this email list. And they said yes. That means if now somebody wants to have help, they write an email and then all of us get the mail. And then I organized weekly meetings so that we all check that we are sort of doing the same things and inform each other what we are doing. And then depending on the request, 2 or 3 of us will together provide joint consultancies. So in general, maybe I think many of you are also providing services. So what I think I can recommend is to also sort of include the microscopy facilities, maybe if you do such a service or do meetings, right? Because that's where the data is generated. So it's good if you keep talking to these people. Another thing I can point out here is Yi. So he has this NFDI logo next to him. So NFDI is actually very fortunate development in Germany. So Germany now thinks we should get better at research data management, and they fund several consortia, among others the NFDI for Bioimage. And there's actually really quite a number of positions funded to make bioimage data and analysis more reproducible and fair in Germany. And Yi is working on enabling bioimage analysis in the cloud, basically in Germany. Then Sebastian and Nima, so we have a collaboration also with a pharma company on the campus, GSK. They work on spatial transcriptomics data, and I personally would like to acknowledge the Jen Zuckerberg funding here. Okay, so, and this is basically what we came up with now. This is an iteration of the last 1 or 2 years. So I can walk you through what we do. And I would be super curious tonight to hear from other people what you do at your institutions. So we have situations where one project can involve multiple scientists and also multiple analysts, right? And then they have to talk with each other in a sort of way that you can track. So for this, for every project that we have, we make a dedicated chat channel in this MetaMost platform. So that works very well. This is really much better than emails because you can actually go back and see what was discussed like 2 weeks ago. And then for each project, we make a GitLab repo. So each project we do has a GitLab repo. And this is where all the code and all the documentation for how to run the analysis is going. Then the question is, where do you run this code, right? So it could be that you say, well, if it's just small stuff, you can do it on a laptop, or maybe if it's a little bigger, you do it on a workstation and so on. I think my latest take on this now, this is pretty new, is that we just do everything on the cluster. And it's just easier actually for us because sometimes we have to run it on the cluster. So I think it's actually better if we just run everything on the cluster. Then it's just one solution, okay? And then we have this is not just for us, okay? So the cluster here is for whole EMBL, but it's big enough to run serious stuff on it. And then actually now I think we will also now use Nextflow to run things on the cluster. I don't know, who of you has ever used Nextflow in their life? Okay, actually not so few. Cool. I will have a slide explaining what that is. Okay, then and then next flow needs so it fetches the code from the GitLab, and actually the scientists run it. So I will show you, we have instructions for them. And then the dependencies we either have from Conda, or there is this easy build stuff. Maybe some of you that run the cluster know that. There's this module load commands. Then the data is on these central group shares. What's really nice now that our the IT department developed this data management app, and we actually mainly use it. So there's a new feature in that you can share subfolders of a group share with whatever people you want. So it goes beyond this world group user thing that the standard Linux provides, which was always a big problem for us because we didn't know how to share data. So this is now flexible. You can really, like on GitLab, say, I want to share with this, and this person. So that's really nice because then the analysts and the scientists can work on the same data without having to copy stuff around. So this is all for the batch analysis. Sometimes you also want something with a GUI. So for this, we have something else. So actually all developed by EMBL IT department mainly, right? So not just, definitely not me. So there is this Kubernetes cluster in which they have Jupyter running, and then something that might be not so standard. There's something called Jupyter Desktop. And this is actually like in your browser, you basically have a desktop, okay? And then there is actually one Docker file that we maintain, and there you just put whatever you want inside. And then we have stuff like Napari, Elastic, Cellprofiler, Fiji, and so on in there. And the nice thing is that this is also with GPU, so people can do deep learning stuff in this platform. So overall, actually not so bad setup, I think. So one technical thing, like where do the analysts actually develop their code? And I think there we have to learn, and I think it's not rocket science, but we just don't do it yet. This thing that you basically develop on your local computer, but then execute or somehow on the cluster, because then we use the same environment for development as for an actual production. And I think there's PyCharm and VS Code and so on, but we just don't have that yet routinely. Then we really struggle with Conda, maybe like many of you. So the problem is if the scientists, once they kind of log in here to the cluster, then they are actually having an EMBL home folder, okay, which this environment can see. And if they have anything in their home folder that has anything to do with Python, then somehow this Conda sees it and everything is a big mess. So in our hands, we really struggle to get Conda isolated enough, and it's kind of every week something breaks. So I don't know, we will probably try replacing these Conda environments by containers and see if it's better or not. So if any of you has experience, please let me know. The other kind of not so cool thing right now is that we have two very different ways how we deploy software here and here, which is a bit annoying. It would be nice if this was all the exact same software, right? For example, tools like Cellpose, Elastic, Cellprofiler, you can take the same executable and run it headless and GUI, which is awesome, right? But then it would be also nice to just use the exact same installation. So again, this is just a technicality where we have to still improve stuff somehow. I would say that would be really nice if there's just one installation for this. Okay, so then the GitLab project. So I think another thing I can highly recommend, and I realized we are not the only ones, is to have to do this first of all, I think is good, and then also have a template that you can use, and then basically for each project you populate it. And that really works. I think it's really nice because you can continuously kind of improve your service by just updating this template, whatever new thing, right? Then also it really helps to make your service more consistent. As you saw, there are like 15 potential people that can help someone. If they all do something else, it will be very quickly a big mess. So it's nice if you constrain people to basically follow the instruction in this GitLab project template. So I think that's worked very well. And I actually, on a hackathon 2 weeks ago, I met a couple of people from other institutions. They do something similar. And we have now a common chat channel here on Zulip. So you can also go there if you want and basically join. And we also thought maybe we do a workshop once where we all meet and exchange how we do stuff. So just get in touch if you're interested in this. So what is in this GitLab repo? Actually, not so much. So well, there is a project, and then actually, one thing is people, this is a recent addition, people should also write why this is exciting. And I think this is, sometimes if you are a bioimage analyst, I think you can feel like people just dump random data on you and want something analyzed, and it can be a bit of a job which you maybe don't love. So I think it's really cool if there's a sentence that tells you why this is now so important that you do it, right? So it's more like a motivational thing. Then we have something about data management and something about the analysis workflow. And the other cool thing is you can then just put stuff here that you would like people to follow if they ever publish their data. Yeah. So this is just nice if it's somewhere documented. So data management, there's actually very little. So people should just tell it where the data is, because I will forget in 2 weeks, right? So this has to be documented and they have to write it there and they have to share it with us using this data management application. And then we really now sit always down with them and nail down the naming schemes. And then if they don't follow it, we tell them, look, no, there was no space a week ago. So remove the space. And that works very well. And the people actually like it because all of a sudden their data also gets more organized. And we are pretty hardcore here, right? And I think it's good you can do this. So that is, I think, a success story. Okay, then the analysis workflow. So I think we have currently here some sort of high-level description than what you would actually measure. And then as mentioned, I think current idea is just run everything on the cluster. So they have to log into the cluster. And then they have to clone once the thing. So you basically copy and paste. And then here you copy and paste that you update the code. And then as mentioned, we use Nextflow to actually then run something. So they have to copy and paste this line of code and press enter. And then they have to copy and paste this line of code and press enter. Of course, all will be updated. So basically this is means just run one script. It has some parameters like an input directory or output directory. This might contain some images. And then the other thing is you have some conflict file where you can tell it, hey, by the way, this is a Slurm cluster. So please run it on the Slurm cluster. Okay. So, and then they have to also do this. And I will get back to the visual QC part in a minute. So those of you that have never seen Nextflow, well, it's a script. So somebody has to write a script. Of course, we do this, so we don't expect this from the users, but it's actually not so bad, pretty readable. So here's a dummy sort of Nextflow script. So basically I have a bunch of images that come from this folder. I want to segment them. I get the labels, and then I will join the images with their corresponding segmentations and measure something. Okay. So I think that's fair. It's readable. And then what actually happens in these processes is you call some Linux executables like cellpose, for example, run it on the image, and then you save the TIFF as an output. Okay, so that would be the first part. What's nice is Nextflow supports all the usual ways how you get code from, like here, this is actually what you would write to get cellpose, at least if ChatGPT didn't lie. So, and actually ChatGPT can write such stuff for you. That's also nice. You can say on the cluster, hey, by the way, I need GPU because it's cellpose. Then the next step would be like, for example, you have a Groovy script, so you run it with in the Fiji context and same stuff. And maybe in this case, where do you get Fiji from? Okay, maybe Conda or something. So this is how you write these things. What's nice is you can run this locally on your computer. You could run it on Slurm, but then also if you are more like, I don't know, you can run it on AWS. All of this is all supported by Nextflow. So for bigger institutions here, so we don't do that. And then you can also share such stuff. If you make this a little bit nicer, you can publish it here on NF Core. And then so as a community, we could also contribute more bioimage analysis tools here. Down here, this is actually also from this hackathon 2 weeks ago, together with Tong, who gave the talk this afternoon, and some other people we hacked to make a minimal Nextflow example of using OMESAR, because we think that's an interesting file format. So you can go to this GitHub repo and contribute or just look at how far we got. Okay, so if you now do this batch analysis, you will have a lot of files, right? That you want to look whether the segmentation and whatever worked. So for this, we are using actually something that I still developed while I had time. So Mobi, it's a Fiji plugin in Java based on Big Data Viewer and ImageLib2. And I added here a new feature, which is called Open Image and Labels. And basically you can say, okay, these are my images, and then you can have here a regular expression this is the segmentations of these images, okay? And then each of these segmentations has a text file with, like, for each object, some measurements, right? So the typical cell profiler output also in, actually, by the way. Okay, and then if you press OK here, you get this beautiful stuff on the right. So it will realize there's all these images. It will just put them in a grid. It will render the segmentations, and it will create two tables. It will create a table for the segmentations, which were here nuclei, and concatenate all the tables that might have been there. And then it also will create a table for all the images, and just making, like in Cell Profiler, there's this one output option, like, and then just compute the mean of all the measurements that you might have here for the nuclei, and then you can look at that stuff. Then there's a feature that you can color, like by any column. So here I colored by some of these measurements, and then you can nicely, you can also zoom out. It scales pretty well thanks to ImageLib2 and Big Data Viewer. I don't know when it will break, but I think a few, I don't know, 100 is probably okay. You see all these images, and you see also which ones are the ones with the high and which ones are the one with the low, whatever you have been measuring. Then what we also have is this three-way interaction between a scatter plot and the table and the image. So like this is now, each dot is one nucleus. If you click on it, it will zoom onto the corresponding cell. And this is actually the cell with the biggest area. And obviously this is a bit of a funny nucleus, so this makes sense. And also you will see which row that was. And this is really incredibly, I mean, there might be other tools, but I think you need something like that, right? I mean, without a tool like that, it's very hard for anyone to check whether the analysis worked or not. And that, I know that's what I'm using these days, and it's just a Fiji plugin, so you can also use it. All right, then training. I can actually slow down a bit because I think I'll be too fast, but that's fine. Courses, okay, so for this, I don't know. So who of you has ever seen this website? Okay, at least a few. Okay, good, good, good. So that's a project I started a couple of years ago. And the reason I started is I went to a course by the Carpentries, and they are amazing. So I really realized you can teach much better than I ever did. And then I was very inspired, but then somehow also I thought exactly this way how the Carpentries do it didn't really work for me. So, and then we built this website where basically it's a more modular version of Carpentries training material, where we have a lot of individual tools, modules that you can teach, like, I don't know, around this number at the moment. And then what's interesting, I think, is so each of these modules has some general explanation for what you want to teach, like this figure, for example, and then it has several activities. So it's a bit like a math textbook, at least how they were in Germany. So you have this top left part of the page where there's the general stuff, and then you have all these exercises, and your teacher tells you to do this, 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 and this. So it's a bit like that. And what's interesting is, so we write these activities in plain text and really remove everything that's specific to any specific implementation. And then you have this drop down, and then you can say, I want to now see how to do that in blah, 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 blah. Okay. So that means you don't have to kind of repeat that stuff if you now want to teach this with any different tools. So I think that's an interesting thing. And it's actually also just interesting sometimes to compare how it would look like in Apari or in ImageJ macro. Okay. So it's also by itself kind of interesting. But then as a teacher, you kind of can choose for which level you want to teach this concept. Yeah, and I think we use this now for all courses that we give, and it works both online and hybrid quite well. And also now I think 10 different people have minimally, actually maybe don't know all of them, have taught similar modules. And since it's on Git, the nice thing is you can have issues, you can have pull requests. So every time you find a bug, you can just fix it and make it better and better every time it's been taught. So I highly invite you, if you want to use this training material, please. That's what it's there for. Then final remark. So who of you has used the band? Okay, awesome. So that's something that has been developed by Yi and Jean-Karim. They are both at EMBL, and that started as an EOS Glyph project and also Denby project. So it's basically like a little bit what I had in the beginning, but now really open access. So you can go there right now and start this thing right now, just with your Google account. So there's no strings attached. Everybody can totally use it all the time. So it's, yeah, just an in-browser desktop, which with the typical softwares installed. Here you see the resources. So the 24 GPU is kind of important because I think we need a couple of them for just rendering. They're also used for rendering. That means 20 are left for computation. That means in practice, only 20 people in parallel can actually use the system. And this is now whenever we do a course outside EMBL, then it's very popular. Like these, as you see, there's a bunch of EMBO courses that basically just use this to deploy the software for the users during the course. And also it's configurable both hardware and software wise. So if you have to run a course and you need a sort of consistent environment for all of them, and you don't want them to use their laptops because it might be annoying with all the conda and so on. So this, just contact us here, and then maybe you can just book it for a week. So it's no problem, doesn't cost anything, and then you have it there for the course, and he will help you putting stuff there that you might need for the course. Okay, and then there's a bunch of other people. I have time, so I can maybe just mention that. So I think all of this is, of course, only possible because we have this really amazing IT department with these super nice people that are just helping us all the time. So this is like, I think, really fantastic. Then there's Lisanna and Renato. So we have this IT community at EMBL. So they are also amazing. Then we have Sarah. So whenever there's some more involved statistics, it's not my expertise. So then I say, go to Sarah. And then of course there's Anna. Some of you might know from Elastic development and other stuff. And then also for publication, of course, our workflow is then that people should put their data on the Bioimage archive. So there's Matthew. So overall, yeah, I'm really glad. I think EMBL is in a pretty good place in terms of covering many different aspects of what you might need. Okay, and with this, I think I will stop, and I'm happy to answer some questions.
Thank you very much for your talk. It's very interesting, especially your Bioimage informatics infrastructure. Although I also agree with you on the Conda, I'm not even sure that my Conda setup will work next week, let alone.
Probably not.
So how would you, how do you say, what is your strategy for research data management in terms of reproducibility, that your workflow done for some images in 3 years time, somebody challenged that image analysis, can that workflow be work in 3 years time or
good question? So yes, so we didn't have that yet, but I think using something like Nextflow is already a good step, because this is something that you can then potentially run somewhere else. I mean, that's at least the promise. Okay, so I think that's strategically already good. What I would hope then is that the image data is on the Bioimage archive. The Nextflow workflow is published on the workflowhub.eu. So that would be the sort of vision. And then actually what we don't yet have figured out where to run. It would be nice if there's just a place in the internet where people can just run this Nextflow workflow, but then somebody would have to provide some IT resources. And I think there's currently nobody that jumps, yeah, please, I do it.
But would your software stack will have a problem that you can keep your software stack over 3 years? Or
I don't know. I mean, like so basically that stuff has to still work in 3 years. Okay. So if these are things with versions that, I don't know, if biocontainers doesn't break and do their job, then I guess probably yes, I hope.
Okay.
but
Thanks.
well, it's a tough one, right? But I think at least it's sort of, in theory, yeah, yes.
Hi. I also have a question on data management side and the data management app. If you could detail a bit more also how or what data management it offers, like in terms of annotations or more metadata experiments.
Yeah. So okay, there's so the data management app is very much just registering your file somewhere so that you know that it actually exists, okay? And also you can say archive to tape, and you can say share with other people at the same institute, and actually they will also implement something, upload to an S3 bucket, which I think is actually something interesting for the future for sharing with the outside, but it's not about like adding fancy biological metadata or anything. For this, there's Charles at the Institute. So he is actually developing really a database. He calls it Lab ID. And there the idea is you can have images and associate them to a microscopy assay and all of this. So I think our plan, and we are not there yet, is that this DMA is sort of the back end thing, and then whatever Charles is doing is kind of the front end where we have more rich biological metadata, but it's work in progress.
Thanks, Christian. That was really interesting. I would be interested to know how you approach kind of the boundary between when you train people to do something and when you take it on as an image analysis project. So I'm at the CRIC here, and obviously, you know, we have a training responsibility. You feel like you want to train people, you need to train people. And then on the other hand, I think recently we've had some examples where we've realized actually it's easy. In this particular case, it's easier, we just do it ourselves. So how do you approach that?
Yeah. I mean, so far there were not so many requests, so mostly we just do it then, sort of. But so what I'm thinking, what I would like to teach people is basically image data handling and inspection. So they should be able, and there I think Fiji is still good, to just look at the data and also do manual measurements to just check if their data makes any sense at all. So this is, I think, should be the responsibility. So this is what, and then we will have now, I think, every year regular courses where we will teach them doing image analysis with Python in a Jupyter notebook. Okay, I mean, it's maybe not, but I think that's something that's accessible enough. And I think that's what I would then expect people maybe to do themselves. And then my idea would be, once they have something, they can come to us and we make a proper script for the cluster out of it. I don't know. That's my current idea. If you have anything better, tell me.
Well, if there's no other questions, then let's thank our speaker one more time.